Stoich 8, practice problem 9. There's two parts. First part, it wants to write the balanced chemical equation for the reaction. The second part, it's giving us a volume of a particular solution of potassium iodide. It gives us its concentration, and it reacts with lead nitrate. It's a 2 decimeter cubed of lead nitrate, and we want to calculate the original concentration of lead nitrate. So first of all, I'll put in the balanced equation there. Got a ratio of 2 to 1 to 1 to 2, and we can see, which is quite nice, that the potassium iodide completely reacts with the lead nitrate, so there's no limiting reactant, so we can get straight on with this. So first of all, we're going to convert volume of centimeters cubed to decimeters cubed, and then once we've done that, we can find the moles of potassium iodide as we're given its concentration here. Then we can use molar ratio to find the moles of lead nitrate, and then we can find the concentration of this just by dividing by the volume of lead nitrate that we have. So let's look at the Stoich roadmap. What we're using here, we're going from volume of one solution to the moles of that solution using concentration. We're going to use molar ratio to find out the other reactant, and then we are going to use the volume of solution to find the concentration. Okay, so let's just check I've got that right. We've got volume of solution using concentration to get moles, and moles molar ratio to get moles of the other reactant, and then we're going to use the volume of solution to find the concentration. Okay, so we've got 5 centimeter cubed of potassium iodide, and we know that 1 decimeter cubed equals 1,000 centimeter cubed. So the conversion factor will be 1 decimeter cubed over 1,000 centimeter cubed. The m going on top because that's what we're converting to. Next, we can use concentration to find the moles from the volume, and the conversion factor will be 0.4 moles over 1 decimeter cubed. Moles going on top because that's what we want. Next, we can use molar ratio between the potassium iodide and the lead nitrate, and that's the molar ratio of 2 to 1. So the conversion factor will be 1 mole of lead nitrate over 2 moles of potassium iodide. The lead nitrate going on top, that's what we're trying to find. And next, we have the amount in moles already, that's what we've calculated. And since we know concentration is moles per volume, we just need to divide by the volume that we have there. We can see that we have a 2 decimeter cubed sample, and so we can add 1 over 2 decimeter cubed to our railway track. Let's cancel all those extra units that we don't need, and quick check for the sig figs. We've got 3 in the question, so we'll put 3 in the answer. Splendid.